Today we invite Professor Tadahiro Kitamura, Institute for Molecular and Cellular Regulation, Gunma University, and interview about the current status, challenge, and future prospects in glucagon research. Thank you for the opportunity. We shall start. Firstly, what is the background reason of increasing interest in glucagon for diabetes research? There are two major reasons. First, incretin-related medicine, such as DPP-4 inhibitors and GLP-1 agonists, has been clinically used and reported that suppression of glucagon secretion is as strongly affected as enhancement of insulin secretion on the glucose-lowering effect of GLP-1. Secondly, there were important findings in the basic research using genetically engineered mice. It has been reported that destroying beta cells by administration of streptozotocin into alpha cell knockout mice or glucagon receptor knockout mice never rose blood glucose levels. Unger et al. Proposed glucagon-centric theory that abnormal glucagon secretion is the main cause of diabetes, since no blood glucose increase has observed even under insulin-deficient condition without glucagon effect. Those findings are the main reason that glucagon regain a lot of attention at glucose metabolism research. There have been selling many glucagon assay kits in the market. Why did you decide to develop new ELISA? There are several assay methods such as competitive radioimmunoassay or RIA, sandwich ELISA, and mass spectrometry or LC-MS/MS. Glucagon is secreted from pancreatic alpha cells after proglucagon processing, and various peptides derived from the same proglucagon exist in circulation. Major difficulty in measurement glucagon is the antibody cross-reactivity with oxyntomodulin and glisantin, which share a common sequence with glucagon. The first developed RIA method used single antibody, showed many cross-reactivity with these peptides. More specific assay has been desired, and developed sandwich ELISA using two antibodies, N-terminal and C-terminal specific. ELISA is getting popular than single antibody RIA method now. LC-MS/MS can accurately measure glucagon. However, it has not been applied clinical use due to its long measurement time and cost. Sandwich ELISA greatly improved accuracy of glucagon measurement and made it possible to detect abnormal glucagon secretion in type 2 diabetes patients, which could not be observed by the RIA method. On the other hand, it has been reported in cases with high glisantin levels, such as pancreatectomy and gastric sleeve resection. A large discrepancy has been observed between ELISA and LC-MS/MS, and existing ELISA kits are not sufficient for glucagon measurement as a clinical assay. Therefore, development of glucagon ELISA with even higher specificity is definitely needed. Could you tell us the detailed features of newly developed glucagon ELISA? The ELISA specificity greatly depends on antibody. We have established several new monoclonal antibodies, recognized C and N-terminal of glucagon from glucagon knockout mice and rats. Then, selected a combination with highest specificity from multiple clones by targeting the measurements by LC-MS/MS. Also, the lower detection range should be 1 picomole per liter or less, since plasma glucagon levels after glucose load become very low. The newly developed ELISA has very low cross-reactivity with peptides that share a common sequence with glucagon and can measure 0.62 picomoles per liter at lower range. We believe that we achieved to develop ELISA with sufficient specificity and sensitivity for the measurement of glucagon in plasma. What is the importance of measuring glucagon accurately in clinical practice? As previously mentioned, although glisantin levels rise by gastrectomy or pancreatectomy, most diabetic patients do not have these operations. However, we found high glisantin levels in approximately 30% of suspected glucose intolerance patients in our recent clinical study. Thus, a certain number of type 2 diabetes patients may have high glisantin levels. Therefore, this new ELISA, which can measure glucagon accurately without cross-react with glisantin, is essential to assess plasma glucagon levels in all patients correctly. Finally, please tell us the future aspects of glucagon assay. It has continued a difficult situation to evaluate the study result properly because glucagon assay system have problems and correct data was not able to obtained until now. To clarify the glucagon's influence on the control of blood glucose, it is necessary to conduct numerous clinical studies using accurate glucagon measurement system and to accumulate knowledge about glucagon secretion mechanisms. 3 significant differences in glucagon have been found between healthy subjects and type 2 diabetes patients. First, fasting blood glucagon levels are higher in type 2 diabetes patients than in healthy subjects. Second, 30 minutes after glucose load, blood glucagon levels decrease in healthy subjects, but not in type 2 diabetes. Third, 30 minutes after meal load, blood glucagon increase higher in type 2 diabetes. Furthermore, while the difference in plasma glucagon levels between before and after meal correlates with blood glucose and glucose tolerance, but it does not correlate with insulin resistance or insulin secretion index, indicating that impaired glucagon secretion in type 2 diabetes patients is an independent pathological condition from insulin. Glucagon measurements may be a new pathological diagnostic marker, independent of insulin. In the future, adding glucagon index to insulin index for pathological diagnosis will enable to therapeutic selection for individual patients and is expected to contribute to precision medicine. Therefore, accurate glucagon measurement is very important, and our achievement of developing high-performance ELISA is a very big step forward in the future clinical application of glucagon.